Section 1.4 covers the topic of trigonometric functions, including signs and ranges of those functions, as well as common identities. This particular video is just going to look at signs and ranges to start with. When we look at our definitions for trig functions in terms of x, y, and r in the Cartesian coordinate plane, obviously we can determine the sign for each trig function based just upon x and y, since r, we noted in class, is always positive. I'm going to use the following chart to summarize the trig function's signs in the various quadrants. I'm going to use the mnemonic all students take classes, moving counterclockwise from quadrant 1. So I would normally just write an A in quadrant 1. So all students take classes. And this helps me to remember that all the trig functions are positive in quadrant 1. The S helps me know that sine and its reciprocal, we'll talk of that in a minute, cosecant, are positive in quadrant 2. And then in quadrant 3, tangent and its reciprocal cotangent in quadrant 3. And 4 would be cosine and secant. Those are positive in quadrant 4. So these are where those are positive. Everything else would be negative. And you can look at the x, y values and determine that yourself. Now, based on this knowledge, we're going to determine the signs of the 6 trig functions for the given angles below. One of the first things I'm going to do is draw the angle and see which quadrant it lies in. So for the first example, 87 degrees, I know typically I have 0 and then 90 and then 180 and 270 and back to 360. So my 87 degree would fall into quadrant 1 somewhere, which means that all my 6 trig functions are positive answers. Now for the 300 degrees, I'm going to be somewhere in quadrant 4, because 300 is between 270 and 360. So for example 2, I'm in quadrant 4, which means since all students take classes, that cosine and its reciprocal secant are positive, and everything else is negative. And then the last one is a negative 200 degrees. Now this is where drawing comes in handy. Remember, a negative 200 moves you clockwise rather than counterclockwise. So this is 0 starting here. I'm going to move a negative 90, a negative 180, and 200 should land me somewhere in here. So a negative 200 degrees is actually in quadrant 2, which means that sine and cosecant are positive, while everything else is negative. So just based on what I know about the angle and where it's positioned, I can already tell you about the signs of the different 6 trig functions. Now, similarly, we can identify the quadrant of an angle if we know something about the signs of its trig function. So this is really moving that knowledge in a backwards way. So we're going to use the next part to identify the quadrant, or quadrants, maybe if that applies, of an angle theta that satisfies the given information. Again, I would definitely draw myself those quadrants off, knowing that I have all students taking classes in quadrant 1, 2, 3, and 4. And we're going to kind of mentally list out where we are. Alright, sine is positive. Well, if sine is positive, that could be the first quadrant or the second quadrant, or it could be both. Now the second piece of information tells us that tangent is less than 0, that is, tangent is negative. Well, tangent is not negative in the first quadrant because nothing is negative in the quadrant of number 1. So in quadrant 2, tangent is negative. So if I want to know what quadrant we're in, the one that meets the qualifications for both parts would be quadrant number 2. That's the quadrant I'm in based on the different criteria that I've been given. Let's try another one. Alright, cosine is negative. So it wouldn't be quadrant 1, that would be quadrant 2 and quadrant 3. Cosine is negative in both of those. Now cosine again is positive in quadrant 4, so it's not going to be in here. And now we want to look at also secant is being negative. Secant is the reciprocal of cosine, so they follow the same pattern. Not quadrant 1, yes quadrant 2, yes quadrant 3. Remember secant is positive in quadrant 4, so this would be quadrant 2 and quadrant 3. And this is not, screen is not wanting to write, so let me scoot over just a little bit. 2 and quadrant 3 would be my answers in this case. So that's just giving us a little bit about the signs that indicate quadrants and vice versa, knowing quadrants could indicate signs. Lastly, we're going to look at the range of the trig functions just to give you an idea about estimating your answer in future sections. Note that sine and cosine both range from -1 to 1. Now what that means is no matter what angle I choose theta to be, the answer to sine of theta or cosine of theta won't be smaller than -1 and it's not going to be larger than +1. Tangent and cotangent range from -infinity to +infinity, so no matter what angle I use, I could get any real number for a solution and it would make sense. It would be reasonable. And then lastly, secant and cosecant range from -infinity to -1 and 1 to +infinity, and so not going to get those fractional answers that are varying between -1 and 1, no matter what angle I choose. Based on this information, we can decide if answers are reasonable or not. For example, 1, sine of theta is equal to 2.5. If I actually found that to be true, would that make sense or not? And of course, this would be an impossibility because sine ranges from -1 to 1, and 2.5 is not within that. Now, tangent of theta being 110.47 is reasonable because tangent, we realize, ranges from -infinity to +infinity. And then the last one, secant of theta being 0.6. Well, secant ranges from -infinity to -1, which does not house that number, and then it skips over and begins with 1 up to +infinity. 0.6 is in this in-between state, so this is also impossible. If I got an answer of secant of theta equal to 0.6, I would know, hey, I have done something crazy. And that's just a little bit of background about your different six trig functions, their signs within the quadrants, as well as their ranges or what answers we should be looking for as we study.